All right, in this video I'm going to be talking about the transformations of the 6 basic trig functions. In this first portion I'm going to use Desmos to give you a nice visual to illustrate how the different transformations affect the graph. Okay, so what does the graph look like when we apply them? So I'm going to just focus on sine of x because the other ones are affected in a similar way. So here I have the graph of y equals sine of x. Okay, so it starts at the origin. If I want to talk about one main cycle, right, this is periodic with period 2 pi, so every 2 pi units it starts to repeat. Okay, so our main cycle starts at the origin, goes up, back to the x-axis, down, back to the x-axis. All right, so let's see how things change when I throw in different transformations. So let's start with increasing the value of a. So here I'm going to go ahead and graph. I've made sliders for A, B, C, and D so I can see how each one affects the graph individually. So right now they're all set so that the graph of h is really just the graph of the parent function sine of x. So if I increase A, say to 2.9, we see that it ends up being a vertical stretch of the graph. Okay, so increasing A beyond 1 is a vertical stretch, and then it changes the amplitude therefore. So instead of the amplitude being 1, so in the parent graph, the maximum here is 1, it becomes 2.9. All right, so if A is bigger than 1, it stretches the graph, has a higher amplitude. If A is between 0 and 1, it's going to end up being a vertical shrink, so we have a smaller amplitude. But then if A is negative, then it ends up being both in this case, A is -3, so it's going to be stretching it by 3, but it's also an x-axis reflection. So making A negative, instead of starting at the origin, going up, back to the midline, if A is negative, it starts at the origin, goes down, and then back to the midline. All right, so let's restore A back to 1. All right, now let's focus on how B changes it. So B is, in essence, being multiplied by x. So and it's inside the sine function here, so that means that it's going to be a horizontal transformation. So if I make B bigger than 1, you can see that the peaks get closer together. So if B is bigger than 1, what it does is it shrinks the graph horizontally, and therefore what it means is that we're going to have, instead of having a period of 2 pi, we're going to have a much smaller period. All right, so changing B will be a stretch or a shrink, but it will also change the period. All right, so if B is between 0 and 1, it ends up being a horizontal stretch. So we'll have a longer period, so it'll take longer for the cycle to happen. And because of the properties of the trig functions, we're not going to have to worry about negative B values. All right, so let's restore B back to 1. All right, let's see how the C value. Okay, so C is inside these parentheses. So C, if I make C positive, what it did was it shifted the graph to the left. Okay, so it's going to now start at -0.5 instead of starting at 0. Again, I like to think of starting at 0 as my representative cycle. As soon as we get one cycle, because these trig functions they're periodic, it just repeats. Okay, so again, instead of starting at 0, 0, if C is 0.5, we start at -0.5. All right, let me restore C back to its value of 0. Finally, let's look at what D does to the graph. So if I raise D, D is on the outside, so we know it's going to be a vertical transformation. And so adding on the outside shifts our graph up. And then if we subtract, so if D is negative, we're subtracting, and it's going to shift our line down. Okay, so so here the x-axis for the original one, for the parent one, the x-axis kind of acts as what I call the midline. It cuts the graph in half. So whatever the D value is here, that's what your midline is going to be. So now everything is going to be relative to the negative 1.1, the y value. Okay, in the next portion of the video, I'm going to talk about how to graph transformations of sine and cosine, following up on the Desmos demonstration, and then I'll do a brief discussion of some of the properties of the other 4 trig functions, so tangent of x, cotangent of x, secant of x, and cosecant of x. All right, so let's go ahead and continue to work with the sine of x. The nice thing is that with some minor adjustments, because the shape of cosine is similar to sine but shift a little bit. With some minor adjustments, we'll be able to get cosine really easily once we know and understand how to graph a cycle of sine of x. Okay, so as a reminder, so here our parent function is y equals sine of x. Here I've graphed just one cycle of it. Okay, so starting at the origin 0, 0. So I like to consider this, as I alluded to in the demonstration, I kind of like to consider this as my first representative cycle, and then I can just extend it from there to, get the rest of the graph as I want. All right, so the representative cycle starts at 0, 0, goes up to a maximum value of 1 at pi over 2. Okay, goes back to pi, so it goes back to the midline at pi, then goes down to -1, and then back to the midline at 2 pi. Okay, so every one of these key points happens at intervals of 1/4 of the period. All right, so that right there is going to be a key observation for us to really streamline and simplify the process of graphing these. Okay, so again, here's our full period all the way to 2 pi, divided into 4, 1, 2, 3, 4 pieces. So we start at the origin, go 1/4 of the way, we go up, back to the midline, down, back to the midline. Okay, so I like to call the midline the x-axis in this case, but in general it's the one that kind of cuts the graph in half directly, vertically speaking. All right, so after these observations, let's go ahead and see how things work when we have a transformation. All right, so more generally, we have this basically encompasses all the transformations we're going to have. So some number a out front, sine of b, so it's important that b is factored out. So this process, again, you can approach this in many different ways. So the process that I'm going to show you is specifically has the b factored out. All right, so if you want to follow my steps, you need to have it factored out because, as you know, order of transformations matters. All right, so then we have x minus c inside the parentheses plus d. All right, since we can reduce, so we're going to take b to be bigger than 0 because we have a property of sine that basically says that if we're taking the sine of a negative number, we can just pull that negative out front. Okay, so that's because sine is an odd function. It has odd symmetry. So again, long story short, we will take b to be bigger than 0. So in that case, so now our amplitude is now going to be the absolute value of a, so it's our vertical stretch or shrink. We have our period, which is 2 pi divided by that number b, the coefficient of x. The phase shift, okay? So remember, c is going to shift the graph left or right. So instead of starting at the origin, it's going to maybe start somewhere else. All right, so that starting point is called our phase shift. If c is equal to 0, then there is no phase shift. And then finally, this d value on the outside that's going to be cutting our graph in half. So basically, we're going to be doing everything relative to this midline, y equals d. All right, so press pause and make sure you have all this down in your notes. All right, let's do an example. All right, here we have y equals 2 times the sine of 3x, then plus 1 on the outside. So we're going to graph one cycle of that. But first we need all the relevant transformation information. Namely, we need the amplitude, period, phase shift, and midline. So why don't you press pause and find those 4 pieces of information. Okay, you should have gotten that the amplitude is 2. The period is 2 pi over 3, so 2 pi over that number. The midline is y equals 1. And nothing is subtracted from x, so c equals 0, which means there's no phase shift. Okay? All right, so now let's put this together to get the graph. So the way I like to do it is as follows. I like to start at whatever my c value is. So in this case, I'm going to start at the origin. And then I will extend that out the length of the period. So I'll extend that all the way out to 2 pi over 3. All right, and then I like to break this up because if you remember, the key points happen at intervals of 1/4 of the period. So I then like to break up my interval here into 4 equal pieces. Okay, so each of those is 1/4 of the period. So the length is 1/4 of 2 pi over 3, which is, cancels here, gives us 2, which is pi over 6. So each of these is pi over 6 units away from one another. So that we start at 0, then we go out to pi over 6. Then we go out to another pi over 6, so 2 pi over 6, or pi over 3. Then 3 pi over 6, which is pi over 2. And then that would be 4 pi over 6, which is consistent with the value we should get, which is 2 pi over 3. Okay, so again, start at your C value, go out the length of the period, divide it into 4 equal pieces. Next up, I'd like to then draw the midline, y equals 1. So I'll get some units here. So then we have y equals 1. I like to draw it dotted. And now our amplitude, so remember, this +1 means we're shifting the graph up 1 unit. So this graph here will go up 1 unit. So the maximum and the minimum are going to be drawn with respect to the midline. They're going to be plotted with respect to the midline. Okay, so again, next, draw the midline. Then take the value of the amplitude, which is 2. We're going to go up 2 units from the midline. Okay, so whatever your amplitude is, go up and then down from the midline that many units. So here we're at 1, 2, 3. So that's going to be our highest value, our max. Then 1 minus another 1 gets us down to -1. Okay, so again, draw your midline, then go up the amplitude and down the amplitude. Okay, next, remind yourself of what your C value was. So go to that x value, so we go to x equals 0. And then the sine graph starts on the midline. So the graph is going to start with this x-coordinate and that y-coordinate. So starting at x equals 0, we go up to the midline, and that's our first point. Then, just one more time here, consistent with the way the sine graph works, if the a value is positive, it goes up, back to the midline, down, back to the midline. It may seem complicated this first time, but I guarantee you do 2-3 examples of this, it becomes fairly routine. Okay, so then 1/4 of the way across a period, we're at the max. Next, we're back at the midline. Next, we're down at the minimum. Next, we're back at the midline. So that right there is 1 full cycle of the graph of y equals 2 sine of 3x plus 1. So the only difference, if this were -2 instead, everything else would be the same. It's just that instead of, so we'd start here at the midline and the C value, but we'd go down first instead of up. So that's what it would look like instead if the a value were negative. So it's very, very, very similar. Okay, so again, it's very systematic, so it becomes routine after a few examples. All right, I'm going to give you one to try on your own. All right, why don't you press pause while you work on that one? All right, you should have gotten that the amplitude is 3, the period is pi, the midline is y equals -2, and again, there's no phase shift here. Okay, again, C is equal to 0, so starting at 0, we go out the length of the period, which is pi. Then we'll divide this into 4 equal pieces. Each one of these is 1/4 of the period away from one another, so 1/4 pi, or pi over 4. So starting at 0, we go pi over 4, then another pi over 4, then another pi over 4. Okay, so these are going to be the key points where we hit the midline, the max, and the min. So then we draw the midline. And then from here, we go up the amplitude and down the amplitude. Okay, so this means our graph is going to range from -5 up to 1. Okay, so I like to be pretty clear that this is my x-axis. You're not allowed to shift your x-axis to your midline. Your x-axis is fixed, and then draw your midline as a dotted line. All right, so next, starting at our c value, which is 0, we go to the midline, and that's our first key point. Then we have to decide, do we go up or down? So do we go to the max next or the min? This 3 here is positive, so we go up to the max, back to the midline. Okay, obviously my scale is not good. To the min, then back to the midline. Okay, if you needed another cycle, you just literally just repeat this. Go out another length of the period and completely repeat it. So however many cycles you need. All right, let's do one with a phase shift, but let me fix this a little bit. So we should be a little bit nicer. At least resemble a sine wave. Okay. Okay, why don't you press pause while you work on this? So remember, when you have a phase shift inside, you have to make sure the b value, the coefficient of x, is in fact factored out. Okay, so it is, and so you're ready to proceed. All right, so you should have gotten the amplitude is 2. The period is going to be 4 pi in this case, so this is 1/2, so it's going to stretch it by 2, by a factor of 2. Midline is y equals 3, and the phase shift is pi over 6. Okay, so the phase shift is where our cycle starts. Right, so it's going to start at pi over 6. Because of this negative here, we're shifting to the right. So c is going to be the negative of this number here. So c is pi over 6. So it's going to be just like the other two problems, only instead of starting at the origin on the midline, we're going to start at our phase shift on the midline. Okay, so go ahead and plot your phase shift and add the full period to it. Press pause while you do that. Okay, so we're going to start at pi over 6, and we need to figure out what is the x value that ends it. So pi over 6 plus 4 pi is where we're going to end. Okay, so 4 pi, so we get pi over 6 plus 4 pi. That is 24 pi over 6. So we're going to end out at 25 pi over 6. All right, next, divide this into 4 equal pieces. And remember, each piece is going to be the length of 1/4 of the period. Okay, so divide that into 4 pieces and figure out what each label should be. All right, 1/4 of the period is 1/4 of 4 pi, which is just pi. So each of these is going to be pi units away from one another. So starting at pi over 6, we add pi. So that's going to be pi over 6 plus 6 pi over 6. So that's going to be 7 pi over 6. Then 13 pi over 6. Then 19 pi over 6. And then finally, plus another 6 pi over 6 puts us at 25 pi over 6, which we should be at. Okay, so remember, this is going to be our starting point on the midline. So now let's plot the midline, which is 3, y equals 3. And then we're going to go up the amplitude and down the amplitude. So 1, 2 puts us at 5. Then 1, 2 puts us at 1. So this is going to range between 1 and 5. All right, now we're ready to get it. So that's all the hard part. So now we remember we start at our phase shift and the midline when it's a sine function. So phase shift, midline puts us here. Then we go and we have to see if this is positive or negative. And I'm intentionally keeping them all positive right now just because I don't want to add another layer of difficulty yet. But just so you know, it's just if this were negative, we would go down instead of up. So that's the simpler part. So it's positive, so we go up to the max, back to the midline, down to the min, back to the midline. All right, so by now, if you're bored and it's routine, that's a good thing because it seems like you have it down. All right, I'm just going to touch a little bit now on the cosine case because it's quite similar. So cosine is really just a shift of the sine graph. So a lot of the stuff is really just identical. So again, we can take b to be bigger than 0 because if b is negative, then the cosine basically, so the cosine is an even function, so cosine of negative bx is just cosine of positive bx. They're equal. All right, so the amplitude, period, phase shift, and midline are all obtained exactly in the same way. Okay, so you can copy this down separately in your notes, or you can just say same as all the information for the sine graph. Okay, and you're going to plot it in exactly the same way with one difference because of the slight difference in the shape of cosine. It's as follows. Okay, so everything is still 1/4 of the period, except the difference here is at your C value, the cosine is going to actually start at its max. So the starting point of the cosine is at its maximum. Then it goes to the midline. Then it goes to the minimum. Then it goes back to the midline. Then it goes to its maximum. So the only difference is where you plot your points. Okay, you get the locations of them the same exact way. It's only do I plot a max or a min or on the midline. All right, then if A is negative, then you start at the minimum. Okay, so if A were negative, instead we would say, okay, we start at the minimum at the phase shift, then the midline, then the max, then the midline, then the minimum. Okay, and then just fill in that information, fill in the graph according to those. All right, so let's do one example. I'm going to have you try on your own because of the similarity to the sine. Again, just figure out where your key points get plotted. So I'll give you one to try. All right, why don't you press pause while you work on this one? Okay, again, always factor out your b first, which it already is in this case. All right, so here is all the pertinent information. So remember, for the phase shift, you actually take the negative of this number. Again, if you're adding pi over 4, it means we're going to shift left. So we're going to start, instead of starting at the origin, we're going to start at x equals negative pi over 4. So go ahead and plot the phase shift, extend it out by the period, divide it into 4 pieces, plot your midline, go up and down the amplitude. Okay, pause and rewind if you need a reminder of that. But it's the same for sine and cosine. All right, so we start at negative pi over 4, and then we go out the length of the period, so that means we are negative pi over 4 plus pi units away. So negative pi over 4 plus pi, that's going to be 3 pi over 4. Okay, so I know that I'm going to end over here at 3 pi over 4. All right, when my phase shift is on the left side of the y-axis, before I do my subdividing, because right now I've just really ballparked it, before I do my subdividing, I like to figure out what 1/4 of the period is. So 1/4 of the period, in this case, is 1/4 of pi, or pi over 4. So I know starting here at the phase shift, each one is going to be pi over 4 units away. So we have negative pi over 4. If we add pi over 4, we go to 0, plus another pi over 4. Will get us to pi over 4. Plus another pi over 4 will get us to 2 pi over 4, which is pi over 2. And then consistent, we would get 3 pi over 4 if we added another pi over 4. All right, so now we draw the midline and go up and down the amplitude. Okay, so up the amplitude takes us up to 3 for our max, and down the amplitude takes us down to -1 for our min. All right, so we have all basically the skeleton of our graph drawn. So we know we're gonna start on our phase shift, okay, at x equals -4, and for cosine, starting at the phase shift, you'll either be at your max or your min. We've got a negative a value, so that means we're going to start at the phase shift at our minimum. So starting here, boom, 1/4 of the period, we go to the midline. The next 1/4 will go to the max. The next 1/4 we go back to the midline. The next 1/4 we go back to the max. So here is one cycle of that graph. Okay, so in summary, for sine, we always start on the midline at the phase shift, and then we either go up or down depending on A. For cosine, we start either at the min or the max depending on A, and then go from there. All right, so that is basically how you get sine and cosine graphs. So if you understand you know, all these little bits of, you know, 1/4 of the period, and then the phase shift is where we start, etc., then you'll be able to take it to the next level, which is modeling. So given data, find a sinusoid. Okay, so a sinusoid is a general description for sine and cosine graphs. So, you know, we'll do later find a sinusoid that models this scenario. All right, let me just briefly touch on the similar stuff associated with the remaining 4 functions. All right, for tangent and cotangent, there's no such thing as amplitude. Okay, so this a value here, you know, might reflect it. It's not quite as important to know and be as thorough about as the sine and cosine cases. Okay, so here it's just going to stretch it out a little bit or make an x-axis reflection. But note that the period will change as pi over the absolute value of b. Okay, that's because the period of tangent and cotangent without a transformation is just going to be pi. So multiplying x by b will change our period. So the only thing I want you to know about these two is that as far as transformations go, is that the period is going to be pi over the absolute value of b. All right, so then for these guys here, all the transformation information is the same as in the sine and the cosine, except for the fact that there's no amplitude. So a here is not going to give you any amplitude value. B, okay, the period will change the same, so 2 pi over b. Okay, and D is still going to be your midline, and C is still going to be your phase shift. Okay, so mainly where your meaning where your cycle starts. All right, so lots of information here, but be sure to rewatch anything and slow it down if you didn't get to write down your steps.